So welcome to this video. So in this video we're going to be solving this problem. The problem statement is we'll be given an array so which contains multiple zeros and multiple ones placed in random order. So our algorithm essentially has to place a group of zeros first followed by group of ones. Essentially we have to sort this array. So for example, if you take this example, where input array is a group of a bunch of zeros and ones placed randomly, and the output of our algorithm should display something like this. The group of zeros should be first followed by group of ones. Yeah, so this is what the problem statement which we have to solve. So we'll be discussing three approaches in order to solve this problem. The first approach is to use a standard sorting algorithm, maybe insertion sort, merge sort, or anything else. Or we can use a standard sort library function. For suppose if we take a Java programming language as an example, in RS class it has a function called sort function. So basically, this method can be used to sort these array, given array. So in either case, even if you use standard sorting algorithm or any sort library function, the best time complexity which we can get in terms of big O notation is like big of n log n, because even the most efficient algorithms can take n log n time in terms of big O notation. Yeah, so this approach I'm not going to detail how the sorting algorithm or sort library function look like. We'll essentially go to the next approach where we'll try to decrease its time complexity. So in this approach, basically we'll be traversing the given array all the way from first element to the last element, and we'll count the number of zeros and ones, and we'll store essentially in a map, or else we can store it in some variables. Let us say c0 and c1. C0 represents number of zeros and c1 represents number of ones in the given array. So once we have count of zeros and ones in the given array, we do traverse the array again, and first we'll put c0 number of zeros, and then we'll put c1 ones. So this is the idea of the second approach. So this is the computer program for this algorithm. So this program is written in Java programming language. So this sort zeros and ones is the main method, so which takes the input as an array of integers. So inside we are initializing two variables, c0 to represent count of zeros, and c1 to represent count of ones. So we'll be initializing these two variables with 0 as value. And then we'll be looping through this array. And when we find 0, we'll be incrementing C0. When we find 1, we'll be incrementing C1. And once we have found the number of zeros and ones in the given array, we'll be looping through the array again. So here, as our first we have to place zeros, right? So if C0 is not equals to 0, we'll be placing the zeros first. So essentially, if a count of zeros is 0, we'll be placing ones in the array. So, and we'll be decreasing the count of ones. So essentially, over here we are placing C0 number of zeros first, and then C1 ones next. Yeah, so this is how the computer program for this algorithm looks like. So essentially, in this approach, um, we first found the count of zeros and ones, and next we are just looping through the array again and keeping C0 zeros first and followed by C1 ones next. Yeah, so this approach can be, here we can see we have two loops, and the time complexity will be like big of n. Yeah, so but even though the time complexity is less, this approach is not a recommended approach, because this algorithm, essentially this is a sorting algorithm, right? This is an unstable sorting algorithm. So what is a stable sorting algorithm and what is unstable sorting algorithm? So I'm not going into detail of what is sorting stable and unstable, but I will just give you an high level overview. So with this example, So consider an example. So where people are standing in a line in a queue to a concert or something else. So each person is standing, standing. He's holding a ticket, and each ticket has something called a priority number. So the person with priority zero will has the eligibility to enter the concert first, followed by the person who is holding a ticket with priority one, followed by the persons who are holding tickets with priority two. So, but the security guard has observed that the persons are standing in a queue randomly, not according to the priority. So now he or she has to sort the persons based on the priority number on the tickets. So now, since if we use any unstable sorting algorithm, so the output will look something like this. So we'll have zeros first, and then group of ones next, and group of twos next. This is fine. But if we go into a group of ones, if we see the person with name Hire is first, and the person with name Kiran is next. This is the result after we have used the unstable sorting algorithm. Whereas if we check the group of ones before sorting, the person with name Kiran is first, followed by person with name Hire. But after sorting algorithm, after executing this unstable sorting algorithm, our relative order in a group of one has been lost because the relative order between these two guys has been changed. Yeah. So this is how the result of an unstable algorithm will look like. Whereas if we use an stable algorithm, so the stable algorithm essentially won't lose the relative order. So the output of a stable sorting algorithm will look like this. So here if we check the group of ones, so first we have person with name Kiran followed by person with name Hair. So this is the same. The relative position between these two guys are same even before sorting. Even if we check group of twos, here we have Johnny followed by Vivek and followed by Vidya. Even if we check before executing our sorting algorithm, the relative position between in a group of two is same. First Johnny followed by Vidya and followed by Vivek followed by Vidya. So a stable sorting algorithm won't lose the relative order in a group. So since this algorithm essentially is an unstable algorithm because we are just collecting the number of counts and we are just placing the zeros and ones randomly now by losing their relative order in a group of zeros or a group of ones. This approach is not a recommended approach as well. So now we'll essentially see the third approach. So in this approach, we'll be using two pointers. So suppose if we say name our two pointers as L and M, so both pointers should start from first element. So the idea of this approach is this L, one of the pointer, let us say L acts as a marker. So a marker in the sense that all the values left to L should be zeros and all the values right to L should be ones. And M is supposed to loop through all the values in the array, and when it finds 0, since M acts as a marker between 0 and 1, when M finds 0, it essentially has to send this 0 left to L. When it finds 1, it essentially has to send this 1 right to L. So how do we do that? This is the idea of this approach. This is the idea of this algorithm. So to do this, to convert this algorithm into a computer program, so first we'll just start iterating M from first element all the way to last element of the array. So then when M finds 0, we have, as we have said, we have to essentially send this 0 left to L. So now since L is starting from 0, L is at the first position of the array, right? So to send L0 to left of L, first we'll swap the this 0 with the element pointed by L, and then we'll increment L and M again. So this will essentially make sure that since we have incremented L after we do the swapping of 0 with the element at L, so this will essentially make sure that 0 is left to L, and also we'll increment M as well. when m finds 1, we don't do any swapping, because when we are when m finds 0, we are just making sure that 0 goes left to l by swapping and incrementing l and m. So this will essentially make sure that all the l goes to left to l. So it means that all the remaining values will be 1, which will be right to l. So that's why when m finds 1, we won't do any swapping. We'll just increment m to the next element. So yeah, so basically it's like this: when we'll increment l only when l is pointing to 0. So this way we can make sure that all the values which are left to l are zeros. Yeah, so this is how this algorithm look is about. So now we shall see the computer program of this algorithm. So this computer program is written in Java programming language. So this is the main method which is going to solve our problem. So zeros and short ones. This will essentially take this input as array of integers, and we'll be initializing two variables, as we have discussed, L and M, both starting from the first element. And then we'll be starting M all the way from first element of the array to the last element of the array. And inside this, when M finds 0, we'll swap the 0 with the element pointed by L, and then we'll increment L and also M as well. So this will essentially make sure that 0 will go left to L. Yeah. So now when M finds 1, if M finds 1, we'll just increment M to the next element. So since we have moving all zeros to left of L, this will essentially make sure that all the ones are at rights of L. So this is how our computer program for this algorithm looks like. So we are just using this L as a marker between zeros and ones, and we are using this M to send to make sure that zeros goes to left of L and ones will be right of L. Yeah. So this solution is a stable sorting algorithm, because we won't lose any relative order between a group. Or here, um, this solution will also have a time complexity of big O of n, because we are only checking out an element of an array once. Yeah, so we can also solve this problem in using a different approach as well. So basically, there is a slight difference between approach 3 and approach 4. So in this approach 4 as well, we'll be using two pointers. So here, but when compared to here, where we are starting both pointers from the first element, here we will start first element from one pointer from first element, and the other pointer from the last element. And then we'll be iterating L and M such that only when L is less than M. Yeah. So we'll be incrementing L and also we'll be decrementing M. So this is what we'll be doing this iteration. So in this loop, when L is less than M, we'll be again over here. If you can see this computer program, over here inside the loop, we'll again loop the L pointer. So we are incrementing this L only when the element pointed by L is 0 and L is less than M. And after this, we'll also do another loop, another iteration of M. So over here we'll be decrementing M. So we'll be doing only this when M is pointing to 1 and L is less than M. So basically what we are doing in this 2 is, so since we need zeros at the left and M and ones at the right, so when L is starting from left, right, from the first element, and M is starting from right, right, it is from last element. So when L is pointing to 0, it is fine. We don't need to do any swapping or nothing else. We don't need to change the position of zeros. So similarly, when M is pointing to 1, we don't need to point anything. So basically, these two loops can essentially stop only when in two conditions: when L is greater than and equals to M, or else when L is not pointing to 0, it means that when L is pointing to 1, and when M is not pointing to 1, and when M is pointing to 0. So in that case, when L is pointing to 1 and M is pointing to 0, these two loops can essentially stop. So here we write the final statement where we do the swapping. So here if L is less than M, this essentially means that L is pointing to 1, M is pointing to 0. We do the swapping with the L and M, and after that we'll decrement M and we'll increment L. So, and then we'll go to the next iteration, and in the next iteration we'll increment L such that we'll pass all the zeros, and we'll decrement M such that it will pass all the ones. And if still if L is less than M, then it means that L is pointing to 1 and M is pointing to 0. So it is a chance to do the swapping between element at L and element at M. Yeah, so this is how this algorithm looks like. So even here as well, the time complexity will be like big of n. Even this algorithm is a stable sorting algorithm. Yeah, so essentially these are the four approaches with using which we have solved this problem of sorting an array of zeros and ones. First we have seen sorting algorithm approach. Next we have seen using count of zeros and ones. Next we have seen a stable sorting algorithm using two pointers, both starting from the first element. And then we have seen approach where we use two pointers. One pointer is starting from first element and next pointer is starting from the last element. Yeah, so this is what is about this problem. So I'll keep I'll give a link of this sheet which I have been displaying here in the description of this video, so that you can go through all the not only this problem, you can go to many other problems. So essentially all the problems which are in this sheet will be can be essentially solved using the pointers algorithm. Yeah, yeah, so that's it for this video. See you in the next.